Okay, class, welcome back. I hope you guys had a restful spring break. We are going to start today 14.3 quadratic equations with complex number solutions. We finished up right before break doing a worksheet that encompassed 14.1 and 14.2. Remember, we were adding and subtracting complex numbers, multiplying and dividing them. We were simplifying the square roots of simplifying the square root of negative numbers. Talked about complex conjugates, so this is a continuation of all of that. We will be solving quadratic equations, and our solutions will be imaginary numbers. So consider the parabola given by y equals x squared minus 8x plus 18. If we were to graph that, it would not touch the x-axis. The graph would be above the x-axis. Therefore, it would have no real roots since it didn't cross the x-axis. However, it does have two roots as predicted by the degree of the polynomial. The degree is 2. They are imaginary, so we're going to find them. And we're going to see that they're going to be complex conjugates of each other. So in example 1, the first thing that we would want to do is write down the quadratic formula. Well, let's first write down what our A, B, and C are. So our A is going to be the leading coefficient of our x squared term. So that's going to be 1. Our B is going to be the leading coefficient of our x term, negative 8. And our C is going to be our constant, so that's going to be 18. Alright, so those are A, B, and C. Now we're going to write down our quadratic equation, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And what we're going to do is we're going to take these numbers. So we're going to take 1, plug it in here. We're going to take negative 8, plug it in here and there. We're going to have to plug in 1 here. And then take our C and plug it in here. Okay? Alright. So, let's do that. So we have x equals negative, what's our b? Our b was negative 8. So let me write these down over here. A was 1, b was equal to negative 8, c was 18. Alright, so negative times the negative 8 plus or minus the square root of b squared, so negative 8 squared, minus 4 times 1 times 18 all over 2 times 1. Alright, so now we're going to have x equaling a negative 1 times negative 8. It's going to be a positive 8 plus or minus square root. Okay, so we're going to have negative 8 squared, so that's going to be 64. And then, so we're going to have 64 minus 4 times 1 times 18. So that's going to give us a negative 8 all over 2. So x equals 8 plus or minus. Now, the square root of negative 8, we can break that up. The square root of 8 times the square root of negative 1 over 2. So we're going to have 8 plus or minus. And then we can break the square root of 8 up. Because 8 has a factor, which is 4. That's a perfect square. So we can say the square root of 4 times the square root of 2 times square root of negative 1 all over 2. So we're going to have 8 plus or minus. The square root of 4 is 2. The square root of negative 1 is I. And then the square root of 2 can't be simplified. And then divide that by 2. Alright, and now we're going to divide 8 by 2. So it's going to give us 4. And then we're going to now divide. So you got to divide each term by 2. So 2i square root of 2 divided by 2. So these cancel, leaving me with plus or minus I square root of 2. Alright, so as you can see, there we have our two imaginary roots, and they're complex conjugates of each other. So one of them is 4 plus I square root of 2. And the other one is 4 minus I square root of 2. Alright, so those are two imaginary roots for this problem. Alright, next problem. We want to solve 2x squared minus 4x plus 18. Alright, first thing to do, let's write down our a, which is going to be in this case now 2, our b, which is negative 4, and our c, which is equal to 19. Alright, and then our quadratic formula, x equals negative b plus or minus the square root. Let's erase that. Of b squared minus 4ac all over 2a. Plug in. So negative times the negative 4, which is our b, plus or minus the square root b squared, so negative 4 squared minus 4 times 2 times 19 all over 2 times 2. Alright. Now, x equals 4 plus or minus the square root. So we got negative 4 squared, so it's going to be 16 minus 4 times 2 times 19. And that is going to give us negative 136 all over 4. Alright. New page. So we have x equals 4 plus or minus the square root of 136 negative Alright. So now we have to simplify. So we have the square root of negative 136, so we can rewrite that as the square root of 136 times the square root of negative 1 all over 4. Alright, now we got to ask ourselves, are there any factors of 136 that are perfect squares? Let's see here. So 136, 4. Alright, so 4 is a factor, so we can break the square root of 136 up as the square root of 34 times the square root of 4 times the square root of negative 1. So x equals 4 plus or minus. So the square root of 4 here, that's going to be 2. And then the square root of negative 1 is I. And then the square root of 34 cannot be simplified any further than that. All over 4. So x equals 4 plus or minus, oh, I don't want to rewrite. Let's divide 4 by 4. So 4 over 4 is 1 plus or minus 2 divided by 4. So if we divide 2 by 2, we get 1. If we divide 4 by 2, we get 2. So this is going to be I over 2, or I square root of 34 over 2. Let me rewrite that. Alright, because up top here, what am I left with? I square root of 34. And then over 2. So our two solutions, x equals 1 plus I square root of 34 over 2, and x equals 1 minus I square root of 34 over 2. So those are two complex conjugates of each other. Alright, the last couple examples focus on determining the nature of the roots. So it is possible to determine the nature of the roots of a quadratic equation without fully solving for the roots. The portion of the quadratic formula under the radical, which is the b squared minus 4ac, is called the discriminant. It determines the nature of the roots as follows. So if your discriminant is greater than 0, you have two real roots. If it's less than 0, which the last two example problems we did, the b squared minus 4ac was negative, so we got two complex conjugate roots. And then if the discriminant is equal to 0, you get a double real root. Alright, so example 3, 4, 5, and 6. Determine the nature of the roots. So for all of these, find your a, b, and c first. So your a, for example 3, is 1. Your b is negative 1. Your c is 100. So b squared minus 4ac, plug in. So you're going to get negative 1 squared minus 4 times 1 times 100. So you're going to get negative 1 squared is 1 minus 400. So you're going to get negative 399. Negative 399 is less than 0. So you're going to have two complex conjugate roots. Alright. Let's look at example 4. Alright. X squared plus 5x plus 1. Your a is equal to 1. Your b is equal to 5. Your c is equal to 1. So b squared minus 4ac, plug in. So you're going to have 5 squared minus 4 times 1 times 1. So 25 minus 4, that gives you 21. 21 is greater than 0. So you're going to have two different real roots. Alright. we'll go ahead and skip example 5. It's very similar. You guys can do it on your own. You're going to get 2 different real roots again. I want to go to number 6. So for number 6, your A is equal to 1, your B is equal to 10, C is equal to 25. So we have b squared minus 4ac. So your b, so we have 10 squared minus 4 times 1 times 25. So you're going to have 100 minus 100, and that equals 0. Alright, so because 0 equals 0, alright, so if I scroll up here, so if your b squared minus 4ac equals 0, you have a double real root. So double real root. Alright, so that's what it means to find the nature of the root. So what you guys are going to do is I've attached this worksheet, and you're going to work through 1, 2, 3, 4, 5, 6. So you have 16 problems to do on your own for homework. Okay, and then I will post the answer key for those problems. So, talk to you guys in a bit.